All right, this is part 2 of the periodic table. In this part, I will talk about the numbers that are outside of the boxes. In the first video, I talked about atomic number and atomic mass, the two numbers that you'll find inside each box in the periodic table. What I'm talking about today are the numbers that you will find outside of the box. There are two sets of numbers. First, there's a set of numbers that goes down the left side of the table, 1 through 7. These are called period numbers. If you look at the bottom of the table, you'll see these two rows that go across the bottom. These do fit into periods 6 and 7. So we can think of this row as belonging to period 6, this row as belonging to period 7. Basically, the periods move along to include the first three elements, then they jump down to the bottom, go across, jump back up to finish off the period. The other set of numbers outside of the boxes are the group numbers. These go across the top. They're numbered 1 through 18. 1, 2, 3 through 12 are down here. We won't talk much about those. And 13 through 18 on the other side. Let's look first at the period numbers, the numbers that go down the left side of the periodic table. This is period 4. I've removed it from the table. Elements belonging to the same period have the same number of energy levels. We talked about how the atom is divided up into two parts. There's the nucleus with the protons and the neutrons. The electrons are in the electron cloud on the outside of the atom. The electron cloud is divided up into energy levels. In these energy levels, you find electrons with similar energy. There are 7 energy levels that we know of. There are 7 periods on the periodic table. The period number tells us how many energy levels the elements in that period have. Again, this is period number 4. Potassium and calcium on this side, bromine and krypton on the opposite side. All of these elements in period number 4 have 4 energy levels. It's that simple. Group numbers relate again to the electrons, this time to what we call valence electrons. The group number tells us how many valence electrons the elements in that group will have. Valence electrons are the electrons in the outermost energy level, the electrons on the very outside of the atom. What we're going to come to find is that those are the only important electrons when it comes to chemical reactions, when it comes to determining how reactive an element is. This is group 2 that I've removed from the periodic table. Beryllium on top, radium on the bottom. All the elements in group number 2 have 2 valence electrons. The period numbers are easier to work with because period directly tells us how many energy levels we have. Groups are just a little bit more difficult because it's not a direct relationship to the number of electrons. For group 1 and 2, it is straightforward. Group 2 had 2 valence electrons. If I picked something out of group 1, it would have had 1 valence electron. The one little thing that we've got to remember is that when we get to groups 13 through 18, we need to drop the 1. Group 13 has 3 valence electrons. Group 14 has 4 valence electrons. Group 15 has 5. 16 has 6. 17 has 7, and 18 has 8. You might be wondering, where's group 3 through 12? Why aren't they on here? And the reason they're not on here is because they're not as predictable. The elements in group 3 through 12 are called transition metals. And the problem with transition metals is there's no set pattern. Most of them have 1 or 2 valence electrons, but there is no pattern that I can tell you. So you don't have to know them in physical science. In physical science, we will focus predominantly on these groups. Group 1 has 1, Group 2 has 2, 13 has 3, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and 18 has 8. Again, just remember, drop the 1s from 13 through 18, and you'll have no problem with this. I'm going to work a few examples to make sure that you have a chance to understand it before we move on to the second part of this. We'll look at lithium and magnesium first. Here is lithium, Li. We want to find its energy levels. We will look to its period number. Lithium is in period 2, therefore it has 2 energy levels. For its valence electrons, we will look at its group number. It is in group number 1, therefore 1 valence electron. The other one I have on this particular slide is magnesium. The symbol for magnesium is Mg, right there, magnesium. Energy levels first, we'll go to that period number, the number on the left-hand side. Energy levels are exactly equal to the period number, so magnesium has 3. For the valence electrons, we go to group. Magnesium's in group 2. Group 2 has 2 valence electrons. These are the ones out of group 1 and 2 where the valence electrons are exactly equal to the group number. Let's take a look at a couple that are not in those first 2 groups. We'll look at fluorine and argon. Here's fluorine. First, we want the energy levels. For the energy levels, we have to come all the way over to the left side of the table. Look at that period number. Fluorine is in period 2. It has 2 energy levels. For the valence electrons, we look at the group number. Here's fluorine again. It is in group 17. Now don't write down 17 valence electrons. We need to remember on this side of the table, we drop that 1. It has 7. Last one, argon. Ar is the symbol. For the energy levels, again, we're going to look at that period number all the way across the left side of the table. There it is. 3 energy levels. For the valence electrons, again, we look at the group. We are in group 18 this time. Remember to drop the 1. It has 8 valence electrons. The key here is remembering which is which. Remembering that the period numbers on the left side are your energy levels, that the group numbers across the top are your valence electrons. Remember that the period number is exactly equal to the number of energy levels. For the group numbers, remember to drop your 1s when you're up here from 13 through 18. The other thing we need to talk about in terms of the periodic table in this particular unit is the type of element. There are 3 types of elements: metals, nonmetals, and metalloids. This dark black stair-step line that I had you draw in on your periodic tables is the dividing line. This dark black line that runs down like a stair-step on the right side of the table marks the location of a particular group of elements called metalloids. Metalloids are the transition between the 2 major types, the metals and the nonmetals. The metalloids are boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. The ones that I've marked in green. These elements are kind of caught in the middle. They're a little bit of both. Everything on the left side of the table, with the exception of hydrogen, everything over here is a metal. Everything on the right side of the metalloids is a nonmetal. Metals on the left, nonmetals on the right. So if you just remember the ones that are on the stair step above or below it, with the exception of aluminum, are metalloids. They're either above a line or they're below a line. Those are metalloids. You remember everything over to the left is a metal, everything to the right is a nonmetal. Hydrogen's that one silly exception. It's an exception to almost everything we learn in chemistry. Hydrogen's a nonmetal. You'll be good to go. Now, somewhere along the way, you were taught the properties of metals and nonmetals. I think it's back in 7th grade they cover this. Just to refresh your memory, metals are lustrous. Lustrous means shining. If you look at my 2 pictures here of aluminum and copper, you can definitely see that they are shining. Malleable means that they can be hammered into sheets, and that's what's happened in both of these cases. We've taken a metal and we've made it flat in order to make cans and vases. They're ductile. That means they can be drawn into wires. This is a copper in the form of a vase. We can draw that into a wire by pulling on it. They are good conductors of both heat and electricity. That's why we make our pots and pans out of them. We make our wires out of them. Nonmetals. Dull, brittle, poor conductors. Dull being the opposite of lustrous. They're not shiny. Brittle being the opposite of malleable and ductile. Brittle means if you hit it, they crack, they break, they crumble into powders. They are poor conductors of heat and electricity. And the pictures I have here are sulfur and red phosphorus. And you look at those, you can see they are dull compared to those metals. Brittle again means that they can be, when you hit them, they turn into powders, as you can see here with the red phosphorus. Very much the opposite of the metals. Once again, if you have any questions, make sure that you post them on the wall, or you ask me sometime during class.